The sent message by sender will not be directly forwarded or communicated to the receiver. The sender of the message needs to include the name or identifiers of the algorithm. The encryption or the decryption is done using a symmetric key algorithm, PGP, expanded as Pretty Good Privacy. Hello students, welcome to the next session of Network Security. In this session, I'm going to explain about a new concept, that is, how do you secure the data at the application layer. You know about the 7 layers of the OSI architecture, isn't it? The first layer in any OSI architecture is always the application layer, isn't it? Application layer is where the user of the internet or network will share his message or will store his message, isn't it? How does the data is going to be, or security model is going to provide security to the data at the application layer? That will be discussed in this session. The first thing is, application layer mainly consists of an email, isn't it? So electronic mail, which we are going to use to send and receive a message, isn't it? Whether you have a sender and a receiver, each sender and each receiver can use an email account. If they are involved in 2 organizations or a single organization, the sender has to send an email to the receiver. How it is going to be done? What is the procedure is, the sender requests for a network connection. Once the network connection is established, the sender can send the message. The sent message by sender will not be directly forwarded or communicated to the receiver, but it will be in a store and retrieve manner. How it is store and retrieve is, the organization where sender is working will have a queue system where all the messages which needs to be sent to someone else will be queued. Whenever the turn comes, the message will be communicated or transmitted to the intended receiver, or else it will be in queue until its priority will arrive. When priority comes, the mail will be communicated or transmitted to the receiver. Okay. In this procedure of email transferring or message communication between the sender and the receiver, we make use of 3 agent or 3 programs. That is, one is the user agent, another is the message transfer agent, and third one is the message access agent. We make use of 3 programs in this. Here we have a diagrammatic representation of the architecture of an email. Every employee in an email is connected to the email server through a LAN or local area network, or employee may be connected to the email server of an ISP through a WAN, that is International Service Provider, with the wide area network. He may be connected to either LAN or WAN. If it is within an organization, within a restricted area, it will be a LAN. If it is outside the restricted area, the sender or the employee is going to involve the wide area network to transmit the message to the receiver. Okay, here we have that diagram where we have the mail servers. Along with that, we have a user agent. What is the task of user agent is to prepare the message. So user agent will prepare the message to be transmitted. Then we have the sender. Sender will use a message transfer agent. What is the role of message transfer agent program? So we have a client server program which is called as the MTA or message transfer agent, a message transfer agent which is a client server program which communicates or which forwards the message to the mail server. So sender is the client in this program and mail server is the server. So we have the client server program which transfers the message from the sender or the client to the mail server. Now, mail server uses the internet to forward the message to the mail server in receiver end. Okay, in receiver end, there will be an MTA server. Here we have the MTA client, MTA server and MTA client. The message will be sent from the client server forwards the message to the MTA client through the internet. It reaches the MTA server in the receiver end and it will be given to MAA server. It is the message access agent. It is also a client server program which has client in the server receiver's machine and server at the mail server's location. So it will be sending the message access agent will allow the receiver to access the mail and reading it with the help of the user agent. Okay, it will make the bob or make the receiver ready to receive the message. Once it is received, the receiver can read the message. Okay, so it will be a procedure where it will be a store and retrieve procedure because the Alice or the sender may send the message at this moment itself, but it is not ensured that or it is not clear that whether the receiver views that message at the same moment when he receives. He may view the message after 2 days or after 1 week or after 1 month. So there is no guarantee that the receiver views the mail or views the message at the same moment when it is received, isn't it? So we have to store the message until user or the receiver views that message, right? Where it is stored, the message that is delivered by the client will be stored in the receiver's machine once until the receiver reads it. When the receiver reads it, he may keep the message or may delete the message. Until he reads the message will be stored in the receiver's system. So it is called as the store-retrieve method of communicating the email between sender and the receiver. Another thing is the sender and receiver can use the message transfer agent directly to transfer the data between two machines. But the thing is, the receiver machine must always be ready to receive a message, and at the same time the receiver has to read the message. Otherwise, the message may get deleted. But it is not possible, isn't it? We cannot expect the receiver to be alert all the time, to be wake up all the time, waiting for the message, and he reads that message. Maybe the mail has received, the message has been transmitted in the midnight or some other time where the receiver may be busy with some other task. He may not read the message at the same moment. To storing this message in a server or the receiver end, the MAA server will help in storing the message, but MTA transfers or receives the message at the same moment, and that message may not be stored if you involve directly both the MTA. That's why the MAA is used, which has the provision of storing the message in the receiver end. What is the security you can give for an email is, one is the cryptographic algorithms. You can use the cryptographic algorithms. In an email security, the sender of the message needs to include the name or identifiers of the algorithm. Which algorithm? To cryptographic algorithm must be used to secure the mail or secure the message sent through the mail must be ensured by the sender of the message itself. Okay. Along with that, it will ensure the certificates. It is obvious that some public key algorithms must be used for email security. We make use of certification authority and certificate checking and authentication before the message is retrieved and stored. Okay, or stored and retrieved, we need the certificates to be attached with the message to secure the data in the mail. Then we have some of the cryptographic secrets we need to know, that is, in an email security, the encryption or the decryption is done using a symmetric key algorithm. We use some of the symmetric key algorithm, maybe DES or AES, which can ensure the single key security for both the sender and the receiver. But the secret key to decrypt the message, the key which is needed to decrypt the message, is encrypted with the public key of the receiver and is sent with the message. So we use the public key sent by the receiver and is sent along with the message to ensure the security. That means receiver will use asymmetric key cryptography, whereas sender uses the symmetric key cryptography. Both the methods are used to secure the data in an application layer. In this, we make use of one program or one special thing, that is the PGP, which is called as or expanded as Pretty Good Privacy. So PGP or Pretty Good Privacy is a special kind of protocol that is used to create a secure email message or to store a file securely for future retrieval. Both sender and receiver, or the MTA and MAA, makes use of the Pretty Good Privacy or PGP protocol to ensure the security of the data not only in the network during the communication, and along with that it provides security for storing the file before it is retrieved for future retrieval. Okay, we have the scenarios where we can use the PGP. The simplest is to send the email messages in a plain text, as we have shown in the diagram. So Alice in this, or the sender, will directly send the data in a plain text form to the receiver. There will be no integrity, no confidentiality included in the message. There is no security provided to the message. Message is sent directly in a plain text form from the sender to the receiver. So we have improvement using the message integrity. We can provide a message integrity here. So the next improvement that we can make with the direct message is providing a message digest, running a hash function to produce a message digest. What does the receiver or the sender will do is, the Alice is a sender. Alice uses her private key to code a message or create a message digest. So digitally signed with Alice public key. She uses her private key to sign a data and creates a message digest. When it is in the receiver end, receiver will decrypt the message using the public key released by the Alice and decrypts the message using that public key. This is another improvement you can do. Another thing, still improvement you can do is by using the compression. Okay, so we use the Alice private key and public key. We use both the private and the public key. Alice uses her private key to compress the data. So the improvement here is the data is compressed. There is no benefit in this for security, but it eases the traffic or reduces the traffic when you compress the data. The compressed data will be executed or applied with the hash function to create a message digest using the Alice private key. So message digest is signed by the Alice using her private key and is transmitted to the receiver. At the receiver end, the receiver or the Bob uses Alice public key to decrypt the message digest and gets the original message or the plain text that is sent. We have a confidentiality with one-time session key. That is another improvement that we can make. Here is a confidential message that has been sent using a session key. Okay, what does the Alice will do is, Alice uses a session key along with Bob's private key and Alice private key. Public key and Alice private key will be used here. She uses digitally signed message digest with her private key, and we have another one encrypted with Bob's public key. Along with that, there will be a session key encrypted with the Alice private key. So you will have private key used by Alice and Bob's public key and creates a message digest along with the session key. Each message will have a unique session key. It is sent along with the compressed message. It is generated as a message digest using the Alice private key. We get the message digest using Alice private key. She encloses that with the session key. Okay, so session key will be encrypted and is sent along with the message. So session key is encrypted with Bob's public key. Okay, when the Bob receives a shared session key with locked or ensured encrypted with Bob's public key, he will use his private key and Alice public key first to remove the session key. He will get the session key and gets the message digest and uses the message Alice public key to decrypt the message digest and read the original message or the plain text sent by the Alice. This is the one-time session key. Once the message is retrieved and is read by the receiver, session key will be no longer useful and is deleted. If the Alice wants to send another message to the Bob, she has to create a new session key. That's why the name is given as one-time session key. So, how do you do the code conversion is another service provided by, it is the service provided by PGP is the code conversion. It uses radix 64 conversion to convert a encrypted code to decryption, or normal plain text will be obtained by using the radix 64-bit conversion. Okay. The PGP at the same time allows segmentation of the message, which allows the message to be sent in a packet form, which reduces the network traffic. The next concept is the key rings. Why do we need a key rings? We use a bunch of keys, isn't it? Which contains the key of a house, key of a vehicle, key of a car. So we'll have so many keys in a single ring, isn't it? In the same way, there is a special provision given by the PGP to create a ring of keys. Why does the key of ring is necessary? Why do we need it? The first necessary is, what we assumed till now is the sender or the Alice is one having a need to send a message to only another receiver. Okay, but the thing is, the sender may have to send so many messages to different people. There is not different systems she has to send the message. Each time she cannot go on searching for the public keys of the receiver to send a message. So what the sender or what a system will do is, it will keep two rings. One is a private ring, another one is a public ring. That concept is known as key rings, that is provided by the PGP. Here you can view the diagrams of four people having, or four systems having different key rings. So here we have the Alice rings. Each user of the system or system uses two rings. One is a ring having pair of private and public key. Its own private and public key will be in a pair which is formed as a ring, or it is stored as a ring. Another ring is the set of public keys of all the other receivers. Okay, all the other users of the system or all the other receivers' public key will be stored in another ring. So this is Bob's ring. Bob also has different private public key pair which is included in a private ring, and then we have the public ring where the Bob uses the public ring to store the public key of the receivers, other receivers. Same with all the other systems. They use one private ring and another public ring. How does the person is going to do this, or how does the person is going to use, or the user is going to use these rings? Whenever Alice wants to send a message, she will use one of the public key of a particular receiver and creates session key using this public key. She creates the message digest using her private key and creates session key using the public key, encrypts the session key using public key. Okay, so this message digest will be forwarded to the receiver. Okay, at the receiver end, if Alice is the receiver, what she will do? She will use her public key to get the message digest. So her public key is used to get the message digest. Once the message digest is used, she will use the receiver's public key to decrypt the message, and she gets the original message. So there are two cases. When a user becomes the sender, what happens? And once the user becomes the receiver, what are the uses of key rings that can be used? Okay. Apart from that, we have the PGP algorithms that can be, or public key algorithms that are used in PGP. We have different IDs like 1, 2, 3 to 100 to 110. We have different algorithms, encryption algorithms, which are assigned with different IDs that can be used. So RSA crypto system can be used for encryption or signing. RSA is used for only encryption. We'll have the ID 2, public key ID. Then RSA used for only signing has the ID 3. So we can use the 3 ID. LGAML, we have DSS, we have elliptic curve, we have ECD-CA, elliptic curve with the DSA, then LGAML, again Diffie-Hellman algorithm. So you can use so many cryptographic algorithms to encrypt the message that is sent through a email. Okay, here we have different symmetric key algorithms that can be used. There is no encryption. IDEA you can use, triple DES, CAST 128 you can use, blowfish. So we have so many different symmetric key algorithms that can be used to encrypt a session key. Along with that, we have so many hash algorithms that can be used like MD5, SHA1, RIPE, MD160. All these are used to create the message digest. We have told about the hash function algorithm in the beginning of the 4th unit, isn't it? So you can review that with the videos or in the notes. So we have the hash algorithms to create the message digest. Then we have the compression methods to compress the message before it is sent to the receiver, because it reduces the network traffic. So we have the ID, uncompressed, zip, ZLIP or private methods. You can use different compression functions to compress a message. Okay. Then we have the PGP certificates that are issued for the message. We have X509 certificates. So protocols that use this X509 certificates will depend on hierarchical structure of the trusted center. We know about the trusted center, isn't it? So it depends on the hierarchical structure of the trust center, that is local, national and international trust centers. The certificate is issued based on those hierarchy. In X509, there is a single path from fully trusted authority to any certificate. So you can release or get any certificate in a straight way using the trusted authority in X509 certificates. Okay. Along with that, we have the PGP certificates. In PGP, there is no need for certification authorities or CAs. Anyone in the ring, the public key that is in the ring or private key can sign a certificate for anyone else in the ring. There are public keys. You can use one public key to sign for other user. Okay. In PGP, there can be multiple paths. In X509, we have only one path. But in PGP, we have multiple paths from fully or partially trusted authorities to sign for any subject. Okay. Then we have the concept about the trusts and the legitimacy, how legitimate it is. The entire operation of PGP is based on introducer trust. It is the trust center for getting the certificate trust we have, and the legitimacy of the public key. We have different organizations or different paths to ensure the legitimacy of a certificate using the introducer trust, the certificate trust, and the legitimacy of the public keys. All these can be used to ensure the authentication of a released certificate of a receiver. Here we have format of the private key ring table. You will have user ID, who is the user of the private ring, the key ID, what are the IDs of these pairs, the public key, the encrypted private key, and the timestamp needed to encrypt and decrypt these keys have been specified in the public or private key ring table. Okay. Now we have the public key ring table. How does it has? User ID, key ID. User ID is whose key is this. So that will be the user ID, key ID, public key value. Then we have producer trust, who is the one who has released the certificate, the certificates that are released for the user. Then who is the certificate trust who has given this, and the legitimacy of the key, that certificate will be there, and the timestamp in which the key has to be used for encryption and decryption will be specified in the keyring table of the public keys. So we have this much about in this session. Let's continue this PGP concept in the next session. Thank you.